Hello everyone, welcome to Brain Blitz Audios. In today's episode of CBSE board exam, we'll be dealing with previous year questions of mathematics in CBSE board exam. Now today we'll be dealing with the 10th chapter in the grade 12 syllabus for CBSE. The name of this chapter is Vector Algebra. So today we're going to be doing easy questions of 1 marks each for CBSE board exam. So let's look at our first question. Find a vector in the direction of vector 2i minus 3j plus 6k, which has the magnitude of 21 units. So how do you do this question? So we need to find a vector in the direction of a given vector. So we have a given vector 2i minus 3j plus 6k. And now we need to find the unit vector for this vector. Confused? Let's start solving it so that it'll be clear. So we consider vector A as 2i minus 3j plus 6k. So this is our vector A. We need to find the unit vector A cap. And how do you find A cap? A cap is equal to A bar divided by modulus of A bar. So vector A divided by magnitude of vector A. How do you find the magnitude of vector A? Easy. 2 square plus minus 3 square plus 6 square, the whole root. And that is 4 plus 9 plus 36, whole root. So that is 49, the whole root, which is equal to 7. So the modulus of vector A is 7. That's how we find the modulus. You just square the coefficients, the direction ratios of this vector. That is 2 minus 3 and 6. And then you square them and you add the squares, and then you take a whole root of that and you'll get the magnitude of vector A. So having enough said, let's find out the unit vector. So vector A, we'll write it as 2i minus 3j plus 6k divided by magnitude of vector A is 7. So what we do is we distribute 7 to each of the terms. So it becomes 2 by 7i minus 3 by 7j plus 6 by 7k. So this is the unit vector A cap. So in our question, the required vector is in the direction of A. So it is in the direction of vector A. So what do? We know that when a required vector is in the direction of another vector A, they have the same unit vector, which is A cap in this case. And we also know that the magnitude of the required vector is 21 units. So this is given value. Let's take that vector as B. So the magnitude of vector B will be 21 units. So we need to find vector B. And to find a vector, you multiply the unit vector by the magnitude of that vector. So B bar will be equal to A cap times magnitude of B. So vector B has the same unit vectors as vector A, so we can put the unit vectors of A here, and we have the magnitude of vector B given. So magnitude of vector B is 21, and A cap, which is the unit vector, is 2 by 7i minus 3 by 7j plus 6 by 7k. So now let's distribute it throughout the terms in the bracket. So 21 into 2 by 7 I cap minus 21 into 3 divided by 7 j cap plus 21 into 6 divided by 7 k cap. So you know that 7 goes into 21 3 times across all of these. So 21 by 7 would be 3. So 3 times 2y minus 3 times 3j plus 3 times 6k. So in the end, we have our vector 6i minus 9j plus 18k as our required vector B with magnitude 21 units and having the unit vector of A, which is 2 by 7i minus 3 by 7j plus 6 by 7k. So this is the final answer. Let's move on to our next question. We need to find a vector A of magnitude 5 root 2, making an angle of pi by 4 with the x-axis, pi by 2 with the y-axis, and an acute angle theta with the z-axis. So pi by 4 with x-axis means that the direction cosine L will be cos of pi by 4, that is 1 by root 2. And m will be cos of pi by 2. Cos pi by 2 is cos 90, which is 0. So we have two of the direction cosines due to the angle that we found. So now let's consider n as cos of theta, and we need to find out the value of n. So what we do know is that the sum of squares of direction cosines is equal to 1, because a unit vector a cap can be written as Li plus Mj plus Nk, and the magnitude of a unit vector will always be 1, so the sum of the squares of the direction cosines will also be equal to 1. So L squared plus M squared plus N squared is equal to 1. So that'll be 1 by root 2 the whole square plus 0 whole square plus N squared is equal to 1. Now what we do is 1 by root 2 the whole square becomes 1 by 2 plus 0 plus N squared is equal to 1. So N squared can be written as 1 minus 1 by 2, which is equal to 1 by 2. So since N squared is 1 by 2, taking square root on both sides, we'll notice that N will be equal to plus or minus 1 by root 2. Okay, so let's take plus 1 by root 2 because the branch of cos will be from 0 to pi. So let's put in the value of n. So n is cos theta. Cos theta is 1 by root 2. And therefore, cos theta will be equal to the value of 1 by root 2 is cos pi by 4. So we get the value of theta as pi by 4. So we found out the third direction cosine, which is 1 by root 2. Now we need to find out the vector A. Or actually we need to find, yes, we need to find a vector A. So vector A will be equal to A cap times magnitude of vector A. And the A cap is Li plus Mj plus Nk. And the magnitude is given in our question, which is 5 root 2. So what we get is 5 root 2 times 1 by root 2i plus 0j plus 1 by root 2k. So over here, when you distribute it, the root 2 and root 2 gets cancelled. So we get 5i plus 0j plus 5k as the answer for the vector A. So the vector A is equal to 5i plus 5k. That is our answer. Let's move on to the next question. Find the angle between the x-axis and the vector I plus j plus k. So we have a vector A is equal to I plus j plus k. what we can do is we can find out the unit vector a cap, which is vector a by magnitude of vector a. Again, magnitude of vector a is no big deal. All of the coefficients here are 1, the direction ratios. So 1 plus 1 plus 1, it's 1 squared plus 1 squared plus 1 squared the whole root. So that is 1 plus 1 plus 1, the whole root. That is root 3. So we have I cap plus j cap plus k cap divided by root 3. So it is 1 by root 3i plus 1 by root 3j plus 1 by root 3k. Now, the angle between the vector and the x-axis. That angle is alpha. And over here we have a cap, and a cap is the direction, represents the direction cosine. So Li plus Mj plus Nk. So L, which is the x component, is cos of alpha. Now over here, we know the value of L. So cos of alpha is equal to 1 by root 3. So therefore, we can write alpha as cos inverse of 1 by root 3. And that is our answer. Simple, isn't it? Let's move on to the next question. Find a unit vector in the direction of vector PQ, where P and Q are the points 1, 3, 0 and 4, 5, 6, respectively. So over here, we're given the coordinates of the points P and Q. So where we can write vector P, so the coordinates we can write as a position vector. So the position vector, so the coordinates are 1, 3, 0. So the position vector is I cap plus 3j cap plus 0k cap. And for Q, which has the coordinates 4, 5, 6, the position vector will be equal to 4i plus 5j plus 6k. So this is, for P, it will be x1, x1, y1, and z1, and for Q, it will be x2, y2, and z2. Now, to find a vector PQ when the position vectors of its endpoints are given, we use the formula x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. And so now what we do is we plug in the values. X2 is 4 minus x1 is 1, so 4 minus 1i, plus for j cap it is 5 y2 minus y1 is 3, and then that's j cap, plus for k, z2 is 6 minus z1 is 0, and then k cap. So therefore we have 3i plus 2j plus 6k as our vector PQ. But wait, the question is not over. We need to find a unit vector in the direction of vector PQ. So we need to find the unit vector of PQ. So PQ cap will be vector PQ divided by modulus of vector PQ. Now, modulus isn't a big deal. Just find the sum of the squares of the direction ratios and then square root them. So that is 3 square plus 2 square plus 6 square, the whole root, 9 plus 4 plus 36, the whole root. So that is 49, the whole root on adding. So then you'll get 7 as the answer for the magnitude of vector PQ. So PQ is 3i plus 2j plus 6k, and then whole divided by 7. So our unit vector PQ cap will be equal to 3 by 7i plus 2 by 7j plus 6 by 7k. So There you have it. We have our answer. Let's move on to today's final question. A and B are 2 points with position vectors 2a minus 3b and 6b minus a, respectively. Find the position vector of a point P which divides the line segment AB internally in the ratio 1:2. How do we solve this question? Well, let's write the position vectors of A and B. So that is 2a minus 3b. And for B, it'll be 6b minus a. And the ratio here is 1:2. So now we just need to put the formula for the position vector of a point P dividing the line segment internally. So now let's write it. So the position vector VP will be equal to L times the position vector of B plus M times the position vector of A divided by L plus M. If you're wondering what is L plus M, so L and M are the parts of the ratio 1:2. So let's plug in the values. L is 1, VB is 6B minus A, plus M is 2 times position vector of A is 2A minus 3B divided by L plus M, that is 1 plus 2. So we have 6B minus A plus 2 times 2A is 4A minus 3 times 2A is 6A divided by 3. So let's solve the numerator now. 6B and 6B gets canceled here. So that leaves us with minus A plus 4A divided by 3, which will be equal to 3A divided by 3, which will be equal to vector A. So the position vector of the point P is vector A. That is our answer. And that concludes this episode of CBSE board exams. So we have a lot of chapters in mathematics covered under our playlist CBSE board exam. We'll provide the link for the playlist in the description down below. So meanwhile, if you want to have more of our useful and interesting content, then don't forget to subscribe to our channel, Brain Blitz Audios. We'll be back with more useful and interesting content such as mind maps, NEET preparation, learner words, etc. So until the next episode, take care, stay safe, bye-bye for now.